Question 5 on worksheet 4 is again a common ion question. I know this because I see two different salts. We have lead fluoride and we have lead nitrate. One of them is going to get the big 3 steps, the whole setup. I know it's going to be the lead fluoride for 2 reasons. One, it's the insoluble salt. Okay, solubility rule 3 says halogens are typically soluble unless they contain fluorides or leads. So this is very insoluble. 2, the question said to find the KSP for lead fluoride. So we're going to start by writing down those 3 steps. So lead fluoride, PbF2, breaks down to give me my lead plus 2 ion and my 2 fluoride minus 1 ions. Because it's a common ion question, I'm going to do an ice chart rather than just a molar ratio. And my KSP expression, KSP, is going to be the concentration of my lead plus 2 ion times the concentration of my fluoride minus 1 ion squared. We have some more information here. We know the molar solubility of the lead fluoride, so what we know is the value of X. Molar solubility is X. It tells you how much of this dissolves. And they gave me X as being 3.2 times 10 to the minus 4. So if 3.2 times 10 to the minus 4 moles per liter of lead fluoride breaks apart, I'm going to have 3.2 times 10 to the minus 4 moles of lead, and twice as much, 6.4 times 10 to the minus 4 moles per liter of fluoride ion. And if this is all that there was, then that would be enough. I'd put that right in the brackets and go. But at the same time, we have lead nitrate, and it's very soluble. Lead nitrate breaks down entirely to give me lead plus 2s and 2 nitrate ions. If 0.1 mole of lead nitrate breaks down, it gives me 0.1 mole per liter of lead and 0.2 moles per liter of nitrate ion. Again, looking for the ion in common, I can see that I've got lead ion here and here. So there's a change that happens, and the change is, in addition to the 3.2 times 10 to the minus 4 moles per liters of lead from the lead fluoride, I need to add 0.1 moles per liter. Now, these two values are reasonably close together. If I add them actually up, I'm going to get 0.10032. Now, we can round this right back off to 0.1 because significant digits would tell us that there's too many factors there. But if you wanted to carry it through, because it's so close together, you actually could carry it through at this point and then round off at the end. On my test, I don't mark against significant digits. So whether or not we're going to round that off or not, the value that we'll put in the brackets for the lead is going to be about 0.1. The value from the fluoride, which we have to square, came entirely from the lead fluoride. We figured that out as 6.4 times 10 to the minus 4. And of course, order of operations tells us square this first and then multiply it by 0.1. And this factors out to 4.1 times 10 to the minus 8, which is the KSP for lead fluoride if it's in a solution containing lead nitrate.